Welcome to the session on applications of forces, modelling with statics. The objectives for this session are to understand and solve problems which involve limiting equilibrium. Let's take a look at an example. A particle of mass m kilograms is suspended by a single light inextensible string. The string is inclined at an angle of 60 degrees to the vertical, and the other end of the string is attached to a fixed point O. Equilibrium is maintained by a horizontal force of magnitude 8 newtons, which acts on the particle as shown in the diagram. Find the tension in the string and the value of m. So let's solve this. We're going to begin by adding the forces to the diagram. So as you can see, there's a tension T in the string and there's a weight mg acting downwards. Let's now take a closer look at our diagram. Here's our particle of mass m kilograms. And the string here, as you can see, is inclined at an angle of 60 degrees to the vertical, and the other end of the string is attached to O. And on the string you can see the tension, or the arrow denoting the tension in the string. And of course we have the equilibrium is maintained by this horizontal force of magnitude 8 newtons. And of course we have the weight of the mass, mg. Let's now have a go at part A and find the tension in the string. Resolving horizontally, we have T sine 60 degrees equals 8. And so rearranging this gives us that T equals 8 over sine 60. And sine 60 is root 3 over 2, or 0.866025, and so on. And plugging this into your calculator should give you that T equals 9.2 newtons. And now for part B, we're required to find the value of m. So let's solve this. Resolving vertically, we have mg equals T cos 60. And here's T cos 60 degrees. And of course, that's offset by mg since the system is in equilibrium. So the force in the upward direction equals the force in the downward direction. And rearranging this gives us that m equals T cos 60 degrees divided by g. And plugging in the value of cos 60 and the value of g and the value of t, gives us that m equals 0.47 kilograms. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at this example more closely. We have a particle of mass 6 kilograms resting in equilibrium on a smooth inclined plane. The plane makes an angle alpha with the horizontal, where sine alpha equals 3 over 5. The particle is attached to a light inextensible string which passes over a smooth pulley, as shown in the diagram. The other end of the string is attached to a particle B of mass 10 kg. Particle A is also acted upon by a force of magnitude F newtons down the plane, along a line of greatest slope. So our plane makes an angle alpha with the horizontal as shown, and the particle A of mass 6 kilograms resting on a smooth inclined plane has weight 6g newtons. So resolving horizontally and vertically, or parallel and perpendicular to the plane, we have 6g cos alpha perpendicular to the plane and 6g sine alpha parallel to the plane. We have the other string, or the other end of the string, attached to a particle B of mass 10 kilograms, and therefore the weight on this particle is 10g newtons. And we also have the tension in the string T at particle B. And also on particle A, we have another force of magnitude F newtons, or F, acting down the plane along a line of greatest slope, as shown here, along with the tension T in the string. And here's our reaction force at A. Let's now take a look at part A. We are required to find the magnitude of the normal reaction between A and the plane. So in effect, this value R. So if we resolve perpendicular to the plane, we have R equals 6g cos alpha. And if we look at our triangle here, where we have the value of sine alpha, which is 3/5, we can create a little triangle as shown and find the other side of the triangle in order to find the value of cos alpha. And using Pythagoras, we can calculate this as shown. So this is equal to square root of 5 squared minus 3 squared, which equals square root of 16, which is equal to 4. So cos alpha equals 4/5. And we can plug that into our equation as shown. And letting G equal 9.8 gives us that R equals 47 newtons to two significant figures. Now let's have a go at part B. We are required to find the value of F. So let's solve this. If we resolve vertically, we have T equals 10g. And if we resolve parallel to the plane, we have T equals F plus 6g sine alpha. And so we can plug in all the various bits and pieces. So plugging in T equals 10g, and F stays as it is, 6g stays as it is, and sine alpha equals 3/5. And rearranging this and plugging in G equals 9.8 gives us that F equals 63 newtons. And now for part C. We are required to state how we have used the fact that the pulley is smooth in our calculations. So let's solve this. The assumption is that there is no friction between the string and the pulley. This brings us to the end of this session. If you have understood its contents, you should be able to understand and solve problems which involve limiting equilibrium. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.